I would, living in a city of millions of people, I think it would be disastrous if everyone dropped what they were doing right now and started thinking about time.
So what I'm going to do is take my Timex Ladies waterproof and I'm going to drop it right in this bowl. Now I'm going to add some eggs for lightness.
Newton's picture of time will work for you at a practical level perfectly well throughout your whole life.
Completely automatic, no hookups needed. Just flick the lever, watch the ball go round.
So I'm Tim Maudlin. I'm a professor in the Department of Philosophy at NYU. My main research is in foundations of physics.
My name is Michael Strevens. I'm a philosopher of science here at York University.
Have you ever tried to define time?
You have to always be careful about what you're willing to define. Usually, the things you can define are things that are not absolutely fundamental, that have parts to them so that you can talk about what they're made of and so on. But at the bottom of all of that definition, there have to be some things that are so fundamental that they're the things in terms of which other things are defined. I think of time that way. I think time is a fundamental feature of the physical universe.
On the other hand, is the idea that the most fundamental and important fact about time is this way that it passes by, that at every moment there's a new moment that is now. And all the past moments are behind us. All the future moments are yet to come. And there's one special moment which is now, which is where we are. Now look at the physics, and there's no now in the physics. There's no special variable to tell you when now is. In fact, when you look at something like the physics of relativity, there's nothing that even looks like time passing. There's a succession of times, but there isn't that dynamic process, whatever it is. I've already told you that I can't tell you what it is. That nevertheless is such a crucial part of our experience of time. So these two approaches to time, which are called, I'm afraid extremely boringly, the A theory and the B theory.
The real issue that comes up in physics is between what McTaggart would have called the B series, where you think of time as being an asymmetric ordering. So the direction of time into the future is fundamentally different than the direction of time into the past. That time, unlike space, as it were, goes forward. You wouldn't quite know what to make of someone who said space goes in some direction. And in the C series, there's no direction of time. All there is you can say that one event happens between two others, but you couldn't immediately say from its nature which way was to the future and which way was to the past.
Many philosophers once thought that the way we perceive things changing in the world is just like the way that a movie presents them to us. We see the way things are at one instant, then the next instant, then the next instant, and so on, and the scene is changing little bit by little bit. And what we have in our heads is something like simply a reflection of that. But it turns out that it's more complicated than that. That the mind seems to be at any moment, in the physicist's sense of moment, representing an interval of change over more than just a moment, over a short but nevertheless non-zero length period of time. So at any moment, what's in our head is a representation of a process of change, something that has a representation that has this flow in it. And understanding how that is constructed by the brain, which we have a little bit of, but we can hope for much more of, I think can really cast a lot of light on what's going on with the sense of flow. One thing that makes it so hard to get a grip on time, metaphorically, is that none of our metaphors are really metaphors. A river flowing is a process that unfolds in time, but it doesn't manage to extract from time something that we didn't already have a grip on.
Why are people so puzzled about the direction of time? I think the answer is because they were using a mathematical language where it wasn't easy to represent the direction of time. You sort of wouldn't know quite how to put a direction in. In this alternative language that I've developed, it naturally arises. You don't even put it in by hand. It sort of is just sitting there in the middle of it, that the possibility that a geometry could have a directed structure to it. And so if you think time has a direction, you say, now I know how to represent that mathematically. And so my project for the last few years has been developing the mathematics and then rewriting some physics in terms of this new mathematics.